Now next topic, that is resolution of vectors. Resolution of any vector, that is nothing but the effective of that vector in particular direction. Now see how one can find the resolutions of vectors. Now see, suppose we have any vector A, this one. Clear? Now suppose we want to represent this particular vector in terms of these two vectors, small a and small b. Then what we have to do? Okay. Then first of all, from the tail of vector A, prepare a line like this. Then after, from the head of this vector, prepare another line, which one is perfectly parallel to vector B. And first line is perfectly parallel to vector small a. Now, locate the point where these two lines intersect. Then after, from the origin of vector capital A, prepare a vector up to this point of intersection. And then after, starting from this point of intersection, prepare another vector up to the head of our original vector capital A. Now, see, this particular vector here, which I am representing by cursor, that is in the direction of A, but its magnitude is not equal to A. But we already studied about the multiplication of vectors by real number. So here, if we multiply this vector small a by any real number, with the help of which we can prepare this particular new vector. Then after, in the same way here, this another vector is parallel to vector small b, and now multiplying it by any real number, we can represent this new vector as suppose alpha b. Now as per vector summation rule, our original vector capital A, that is the vector joining to the tail of this lambda a vector to the head of alpha b vector. So we can write vector A, that is equal to vector lambda a plus vector alpha b. So we can say this lambda a, that is the resolution of vector A in the direction of small a. Alpha b, that is called resolution of vector A in the direction of vector B. And resolution is nothing but, after all, effectiveness of vector in that particular direction. So here, in other words, we can say effectiveness of vector A in the direction of small a, that is lambda a, and effectiveness of vector A in the direction of B, that is alpha b. This is the concept of resolution. Now next topic, that is unit vector. Unit vector is a vector having magnitude equal to 1 unit. Magnitude equal to 1 unit. Unit vector is represented by a small letter, any small letter that you can use to represent any arbitrary vector. Here, vector, unit vector is represented by symbol small u. But How one can say this one is the unit vector? So to represent it here on the symbol, means on this letter, which one is used, on it we have to place the symbol of hat or caret. This particular symbol is read as hat or caret. So we can say this one is u hat or u caret, and that is the unit vector. એટલે આ ટાઈપનો સિમ્બોલ આવે તો સમજી જવાનું કે એ યુનિટ વેક્ટર છે. And magnitude of it, that is always 1 unit. Okay. Now see how this one is useful to represent any vector. To understand this thing, let's take one vector A. Now suppose magnitude of vector A, that is 3 unit. That is 3 unit. Now if we consider the unit vector in the direction of vector A and say that is UA. અહીંયા સફિક્સમાં મેં A એટલા માટે લખ્યો છે કે આપણને ખબર પડે કે this unit vector U is in the direction of vector A. એટલે અહીંયા સફિક્સમાં આપણે A લખ્યો છે. Now see, suppose I prepare one unit vector UA as shown in the figure. Then from the head of first unit vector prepare second unit vector UA. Then after from the head of second one prepare the third unit vector UA. Now if we take the resultant of these three, means if we take UA plus UA plus UA, then that will be your A, because magnitude wise UA, that is 1 unit, this is 1 unit, this is 1 unit, and all these three are in the same direction. So resultant magnitude, that will be 3 unit, and the direction of this resultant vector is in the direction of A. So simply here we can write vector A, that is equal to UA plus UA plus UA caret. So we can write vector A, that is 3UA caret. So we can write UA caret, that is vector A upon 3. But 3, that is the magnitude of vector A. So here 3 is replaced by magnitude of vector A. So now this one is generalized one. If you want to find unit vector in the direction of any given vector, then very simple thing, divide that vector by its magnitude, you will get the unit vector in the direction of that vector. Suppose you have magnitude of the vector as well as unit vector in the direction of that vector, that we know, suppose, then how we can represent the vector? Then from this equation we can write vector that is equal to magnitude of the vector into unit vector in the direction of that vector. So in this way one can represent any vector A with the help of its magnitude and unit vector of its direction. Clear to all of you? Any doubt in this one? Now for x-axis, y-axis and z-axis, the unit vectors are represented as I caret, j caret and k caret respectively. These symbols will never change. Compulsorily, we have to use these symbols for this respective axis. The unit vector of x-axis, that is always represented by small I caret. Unit vector of y-axis or in the direction of y-axis, that is always represented by small j caret or j cap. And the unit vector in the direction of z-axis, that is always represented by k caret. Okay, so unit vectors of the axis are represented like this. Now clear to all of you?
Yes, sir.
Clear. Suppose we have any vector A as shown in the figure having magnitude equal to A and is in the direction making an angle theta with x-axis. Now this vector is represented in 2 dimensions, and now we want to find the resolution of this vector, or resolution is also known as components of this vector in x direction and in y direction. Now see, for that what we have to do, from the head of this vector A, draw normal on x-axis and draw another normal on y-axis. Then after, prepare a vector from the origin of the Cartesian coordinate system to this normal point on the x-axis and say that vector is vector A1. Similarly, prepare another vector from the origin to the normal point on the y-axis and say that particular vector is A2. So from figure you can understand, if this vector is A2, then from the head of A1 you can prepare this vector that is also A2. Now as per summation rule, we can write vector A that is equal to vector A1 plus vector A2. But see, A1 that is in x direction. So we can say, suppose its value or magnitude is Ax and A2 is in y direction. So say its value or magnitude is Ay. Now this vector A1 that is with magnitude Ax and is in the x direction, and unit vector in the x direction is I caret. So we can write A1 equal to Axi caret. Similarly, A2 equal to Ay j caret. Clear? Now we can say resolution of vector A, that is Axi caret in x direction, and resolution of vector A in y direction, that is Ayj. But resolution that you can represent in terms of component also. So you can say Axi vector is x component of vector A and Ayj caret, that is y component of vector A. Clear? So in component form, any vector can be represented by this type of equation. Now, suppose you have magnitude of the vector A. Then with the help of it, how you can find the x component and y component? So we have direction of it. Suppose we take cos theta, then that is adjacent upon hypo. So adjacent, that is hypo into cosine, so that is a cos theta. Then similarly sine theta, that is opposite upon hypotenuse. So sine theta, that is Ay by A. So you can write Ay that is equal to A sine theta. Means suppose we have magnitude of any vector and its direction, then using it easily we can find its components. And suppose we have components, then simply we can represent that vector A, that is AXI plus AYJ. But see, this AX and AY perpendicular to each other. So we can find the magnitude of vector A by using Pythagoras theorem. Magnitude of vector A, that is under root AX square plus AY square. And we can find the direction also. Tan theta, that is AY by AX. So if we have AX and AY components, then take ratio AY to AX, you will get tan theta. And from that find out theta. So you will get the direction. Now this equation AXI plus AYJ caret, that can be represented as AX is replaced by A cos theta, AY is replaced by A sin theta. So we can write vector A, that is equal to A cos theta I caret plus A sin theta j caret. You can take A common also. Clear? So in this way, vector A can be represented with its components. So from the vector, how one can find its component, and with the help of components, how one can find the vector, that we discussed here. Clear to all of you? Any doubt? Now suppose we want components of vector A in 3 dimensions. Very simple. Vector A, that is vector AX plus vector AY plus vector AZ, where vector AX, vector AY and vector AZ are the components of vector A in X, Y and Z direction respectively. Now suppose vector AX is with magnitude AX and it is in X direction, so you can write vector AX equal to AXI caret. Similarly, vector AY, that is AYJ caret, vector AZ, that is AZK caret. So magnitude of vector A, that is under root AX square plus AY square plus AZ square. In 2 dimension we can write magnitude of vector A, that is under root AX square plus AY square. And now if you want the angles made by this vector A with respect to x-axis, y-axis and z-axis, and suppose you have magnitude of A and the angles with respect to x, y and z-axis, then how you can find the components? So component AX, that is A cos alpha, where alpha, that is the angle made by your vector with x-axis. Now if you want to find alpha, then you can take cos alpha, that is AX by A. Similarly, AY, that is A cos beta, or cos beta, that is AY upon A. Beta, that is the angle made by vector A with y-axis. Similarly, AZ equal to A cos gamma, or cos gamma, that is AZ upon A, where gamma, that is the angle made by this vector with respect to z-axis. Clear? So in 3 dimensions, we can represent the component of vector A as AXI plus AYJ plus AZK caret. Clear to all of you? Any doubt?